So, gentlemen, welcome to the Drive for Innovation.
Thank you. Thanks for coming.
So, EIT has been around since 1977.
Correct.
And this is yet another contract manufacturing company that we've come across on this trip that's thriving and growing. And I think you mentioned that you had your best year last year. What's going on?
Well, I think more and more with the down economy, you'll see more and more OEMs outsourcing, so that helps contract manufacturing. EIT is a little bit unique. We've been here for 35 years. And the way the company started, Joe May, who's our founder and chairman, actually used to work at DuPont and decided that that wasn't working out and decided he wanted to go off on his own. And when he did, he moved to Northern Virginia and was doing some sales, and DuPont called and said, hey, can you develop some product for us from an engineering perspective? So he did, and they said, that's great. Now if a company in Northern Virginia started up and could actually build these products for us, that'd be great. So that's really how we got our start in contract manufacturing. In fact, 35 years later, we still work with some companies that were spin-offs of DuPont as well. So we call those our evergreens, and we have about 5 to 6 companies that have been with us for 25 years or longer. Some are here for 35 years, right from the beginning.
So your main business is contract manufacturing. However, you have a very important niche business in UV measurement.
The products that we sell for UV are process control instruments. A lot of technologies. You talk about the green car that you have. UV is a green technology. There's no VOCs or no solvents. And what we're doing is bringing a way to measure how strong the UV source is when they're curing coatings, inks, adhesives, and resins. It could be anything from a medical application to electronic application to things as basic as curing of wood floors. The long-lasting wood floors that you have are made with UV. So it's a niche that we developed. We actually got a bad bunch of boards in 1984 that were made with UV. They weren't cured properly, and it was significant impact on cost for EIT. And Joe and the other engineers said there's got to be a better way. So now we've got about 13 or 14 different products based on the applications for that we sell. It's really the only thing that goes out of here with the EIT name on it.
Interesting innovation strategy, right? You're presented with a problem and somebody internally says, well, we can fix this. Let's break off a team, and then it becomes a business line.
It becomes a business line. For some folks, that's all they know EIT from is from our UV products, versus other folks know us mainly as a contract manufacturer.
It's interesting that you're here for Drive for Innovation, because I think that's really a differentiator for EIT. We're not just a contract manufacturer. A lot of our products, and you talk to some of our existing customers, they'll say that we know the product better than they do themselves, because the engineer who designed it has since moved on to a different project, but we've been building it for a whole bunch of years. And that's, I think Joe has 23 patents to his name right now, and there's a few more in process. And again, it's innovation, just things like he recently got his helicopter license. So now we're looking at a few products that could enhance that experience for a helicopter pilot, height above terrain, different kind of things that we're looking into. So it's not that we're out trying to develop, new things. It's just everyday life that he's come across and said, how can we enhance it and make it better? So, and that's really how we got to where we are. And the engineering is really what differentiates us from other CMs, I think, in the world.
So what you're saying is Joe sometimes uses interaction that he's doing, flying or something else, to kind of figure out how to work that into product design and manufacture?
Yeah, and Steve's group really heads that up, and it's not just Joe. We have the strong engineering group that Steve heads up that is really support for manufacturing. We have process engineering on the floor that makes sure the right documentation is in the right place, and we do the oven profiles correct, those kind of things. But it's this different engineering group that comes in and says, hey, there might be a better way. There's a better mousetrap. And that's what these guys do. They'll come down and, to me, my background is accounting, so these guys are scary smart. And as Joe says, every once in a while we throw them a piece of raw meat and say, here, figure this out, and that kind of keeps them engaged.
Yeah, we have a couple of good examples where, as Dave says, we, in certain products, know our customers' products as well or better than they do. We've been dealing with them so long. And we have found in there are instances where their design is actually taking advantage of certain attributes of components that aren't particularly specified by the manufacturer, but they're making use of these attributes. But because they're not specified, they're not controlled. And in some cases, they may not understand they're actually doing that. We've been able to go into some of those products where we find fallout in functional test because not every component performs exactly to that attribute's requirements, and because it's not specified. We were able to go in there and understand that, and then develop some fairly sophisticated fixturing to try and detect that particular component's performance and select them for the attributes that the customer is really relying upon for it to function properly in his equipment. And at the end, give him a much better quality, very low fallout at functional test. And in these areas where the customer themselves may not understand the performance issue that we're dealing with, but we like to go in there and give him that little extra, and at the end he gets a product that works, and we've taken the extra step to make sure that EIT knows how to do that for them.
Let's talk a little bit about your engineering team, because obviously that's a value add. You're not just a board stuffer, if you will, or a box maker. How are you seeing customers with the increased design complexity that they're having to face leveraging your engineering organization at one level or another?
Absolutely. Again, it's in the areas, a lot of these customers, they develop a product and their engineering team is moving on to their new designs. They want to move on to their next product. Sustaining engineering is always a continued issue that you have to deal with on existing products. And again, customers' design teams focus on new things. We can kind of come in and help them out with the sustaining portion. We can deal with obsolescence. We've dealt with several products where we've been able to go in and design out an obsolete part without affecting their overall design, and actually create a drop-in component for them that their board looks like the original component, but we custom designed our own component to perform in the same way that the obsolete part did. So we're able to give them that kind of a backup where they don't have to put all that energy into keeping the product going. We can do that for them.
So the prevailing wisdom is that contract manufacturing is dead in the United States. It's too expensive, real estate's too expensive, the degrees that you have to hire in the engineering department are too expensive, and it's much better if you do it over in Shenzhen or the Philippines or someplace like that. Turns out that's not really the case.
It's really not. Again, my background is accounting, so I can tell you we can't compete with the labor rates in low-cost regions of the Far East or even in Europe. But if you look at total cost, we can be very competitive. We're not going to build cell phones. We're not going to build smoke detectors, something that you're making millions or hundreds of thousands of at a time. But in the medical market, in the industrial market, there's still a very strong presence needed from the U.S. perspective. In fact, 2 weeks from now, we're going to have a grand opening we just built a new building down in Danville, Virginia. And Danville is somewhat of a lower cost region. We call it our solution to offshoring because our infrastructure there is a lot less. So we have our accounting functions and HR functions here. And down there, we just have a pretty strong workforce. The people are used to working because it used to be the tobacco industry, and there's a lot of people available. Unemployment's very high, so we can go and get the resources we need. We have a lot of support from the local colleges and community to get training for our people down there. So what we do is we have one ERP system, one quality system, and we manage product from here. Typically we introduce the product here, make sure everything is okay, and then if it makes sense, we'll take it to Danville and do the production down there, the higher volume productions.
We have had customers come back to us after they leave us for price. They come back to us for value and quality. I think it's hard to put a price tag on things that we do from an engineering standpoint, but instead of just being a board stuffer, they realize that maybe their design, we don't want to call their baby ugly, but maybe their design's not ready to move offshore. Maybe it's in transition, maybe it's not stable. So we offer those types of things. The other thing that we offer from EIT is we do offer from a prototype all the way to the grave type of support with that. So if somebody starts with our engineering team, we can take it through their prototype phase, through early production. Then if it gets to the point where maybe it's too big a volume for EIT, maybe it's 1 million or 2 million units a year, we do have the resources available. We can also support it from here through low-cost region manufacturing. So we're able to support customers from the one prototype up to millions of units through relationships that we've established.
So you have some eye candy here on the table. Walk us through some of those devices.
What these are products here that we've designed here, the engineers at EIT have designed, and many they're on their second and third generation, and they're a combination of electronics and optics. The optics are on the back. We would expose this side to a UV source, and many times it could be 100 or 1,000 times brighter than the sun. And what we're going to do is, in this particular case, look at different colors of UV. You think of visible light as red, orange, yellow, green, blue. UV is actually measured, it's a little bit shorter, you can't see it, but there's short wavelength UV all the way up to long wavelength UV. Each of those have different properties in how they're going to cure the coating or adhesive or resin. So this will be passed through the UV source. Then we would get two main values from this, the power coming down, much like the rainstorm coming down, and then how long it's going to rain. We have the time integration of that, the watts and the joules of the UV source. And people are going to establish a process window, then use it to monitor and maintain that then on a daily basis in production.
That's neat. What else do you have over there?
Well, this is the same size as a CD. CDs used to use UV. There are not probably as many made now, but this is one that we have that is much smaller. And with this one here, you can get this onto small objects here. You're able then to put it back into this reader and then get the same type of information through this reader here. This is the small radiometer here. We also get into types of things where you can mount products that we make inside the UV source for continuous feedback. A lot of times the folks that have a very tight process window need continuous feedback with the UV products. We also do things where I can actually hook up to 32 sensors to this, something like a car fender or something like that, or a dimensional object. I can get readings from 32 different areas and allow folks then to adjust the robot or the light sources then, so you have an even amount of UV being brought down to the surface then on that large object. So it's a matter of us responding to the demands of the market, listening to our customers, going back and seeing if we can find a solution for that.
So we've talked about how you guys are delivering competitive services, obviously competitive solutions, or actually well-designed niche solutions. There got to be challenges, engineering challenges, whether it's finding the right skill sets coming out of schools or, I don't know, local government regulations. What keeps you up at night?
Well, I think if you want to talk specifically to this area, some of the new challenges are our customers are moving to new technologies to develop the UV radiation, where they're going from mercury lamps to very high energy LED technology, which has a very different spectral development. And so we're looking at some of our instruments to be able to tune them better to work in those kind of environments rather than the older lamp environment. So that's been a challenge for us recently to come up and look at the design of these instruments, how to improve our filters, how to improve our optics to allow our customers to take advantage of higher LED technology versus lamps. And also you mentioned engineering talent. We have a very mature engineering organization here. It's been around quite a while. And
also very diverse, as we saw outside.
Exactly, but we've been looking at younger people, younger students, and we've just recently hired 3 young engineers. Recently graduated from the University of Virginia Tech, and it's been an interesting process. Again, being a mature group, we've been around for so long, we've forgotten in a lot of ways what you learn in the real world as opposed to what you learn in school. So it was interesting to find out that they were young, they were green, and needed to learn a lot about the real world as opposed to the theoretical world of engineering. But conversely, as we've taught them that, they've brought new ideas to us. They're younger, they're very, very smart. They've been very well trained in school. They've grown up with technology in a different world than we more mature people did, and have really brought an interesting and different point of view, and have really been beneficial for us to bring in some younger people like that to give us a different viewpoint.
That's a good perspective, because we go to these universities, we're going to go to a high school this afternoon, and they all are making robots and remote control helicopters, and they have all these competitions. They have stuff available to them that we couldn't even imagine.
Exactly.
And so it's good to hear that's kind of bubbling into the organization.
Yeah, you really see it come up. They've got a broad range of knowledge, much broader range than I could say I would have had at their age back several decades ago. Like I said, but then again, we have to bring them into the real world of how to take that design information, how to take that technology, and actually turn it into products that can actually be manufactured and be manufactured cost effectively. And so it's been kind of a learning experience for both of us as we deal with the younger people. It's been fun.
Neat.
I think one of the other challenges that we have as a business is making sure that our goals are aligned and on the same page as our customers' goals. If a customer just wants a price as their main driver for using EIT, we're probably not a good fit. We sell on value, deliver on value. What's the overall performance that we have? Can we make some cost reduction suggestions for you? Can we make things that other people do not make or have trouble struggling to make? That's, I think, the overall package. And it's qualifying the customers before we get involved and making sure that our goals are aligned with theirs and moving forward to understand. We have to obviously pay our engineers, and the value that they deliver, we feel, is outweighs maybe another dollar or two in the cost of an assembly.
And I think that's a real important piece of our success. We're not out looking for just pound on the pavement for any kind of customer. We spend a lot of time qualifying who's the right fit for us. It's really about partnership to us. A couple of years ago, one of our biggest customers, it just wasn't a fit for us. And we disengaged with them, and they were pretty shocked and surprised by it. And probably internally we were too, but it just wasn't a fit. They didn't have the same approach as we did. You know, cost was very important, where cost is important to us, obviously, but it's more about value and about quality. So we want to make sure we have the right solution, and we want to be able to say, here's an engineering group. You can get anybody to stuff a board, and if you want to, that's all you're interested in, then we're not the right place. But if you have a board that has some potential challenges or some risks, either for obsolescence or just not designed for manufacturability or designed for testability, we can help you with that, and we want to help with that. So then we take kind of ownership of the product, and that really develops the relationship. That's why we have some of our customers here for 25, 30 years, 35 years.
So you have a potential audience through this of EDA vendors, machine vendors, test and measurement guys. What's your biggest gripe to them that they should fix right now? And don't say price.
If you look at from a material standpoint, I think the lead times have been a challenge. And irregardless of price, it was a 4-week lead time, now it's a 16-week lead time. That is a challenge for us to count on that year after year. We still are being pushed by our customers to reduce costs wherever we can, and we look to do that the best we can. But I think it's uncertainty with the supply side of things and what the costs will be this year, maybe possibly next year.
Yeah.
And you know, from equipment side, I think you know, if you look at the technology, it's so ever-changing and changes so fast. I mean, components are so small now, and the expectation of what they can do is such a challenge. So to try and develop tests for those and try and develop the components themselves, okay, here's what it's trying to do, but the customer only needs it to do this. That's where, you know, our engineering group really gets challenged on a daily basis. So that's going to continue to evolve, but that's a big challenge for us. You know? Yeah.
But on the flip side of that question, I think one of the things that a lot of the suppliers do well, because again, their value added is not just they want to sell material, they want to sell components. They've really worked hard at providing the support to the engineering teams to get us the information we need to make the proper component selections to help support the process or the component selection through its lifetime. So I think that's one of the things they do well. I think with the same mode that we bring is we're going to give you more than just components. We're going to give you support. We're going to give you engineering technical assistance to make the right selection to get their products designed in. And I think they've done a pretty good job with that.
Good stuff. Thanks, guys.
Thank you.
You're welcome.